Okay, so picture this, right? Medicine, but like totally tailored to your DNA, like treatments that are, super effective because they're like designed for you.
It's the future, right? Personalized healthcare. It's
Yeah.
what we're all hoping for.
Yeah, exactly. But there's kind of problem. What if like science hasn't even really looked at your DNA?
Yeah, that's the issue we're gonna dive into today. Actually, the lack of diversity when it comes to genetic research.
It's a big one. It's a big roadblock to like, personalized medicine actually working for everyone.
Huge barrier, and we're going deep on this today. We've got excerpts from this Knowable magazine article.
Oh yeah, I love Knowable magazine.
Yeah, and it's written by a bioinformatician who's working on this problem.
Oh cool. So like right from the source.
Right from the source. Get ready for those aha moments.
Oh, I love those. Okay, let's jump right in. Let's start with an example. The article talks about warfarin, right?
Yeah, warfarin.
It's a blood thinner, super common, but it can actually be pretty risky for some people because of their genes, like how they process it.
Yeah, genetically, people process things differently, right? And warfarin is a great example. It's actually one of the top drugs that leads to hospitalizations because of adverse reactions in South Africa specifically. And while the data is limited for other parts of sub-Saharan Africa, it's probably safe to assume that it's an issue more widely.
So this isn't like some theoretical thing, right? Like this is real people.
Real people
ending up at the hospital because of like their genes, their genetic makeup wasn't considered.
Right. It's not hypothetical. This is really happening, and it's a great illustration of the core problem, which is this bias in most genetic research. The majority of research focuses on people of European descent. And that leaves other populations, understudied.
Yeah, which is a problem. The article actually mentions a study. It was about warfarin.
Okay.
Back in 2010. And they found that genetic info, it actually helped with like figuring out the right dose for white people. But it didn't do anything for Black, Chinese, or Japanese people. Like no benefit.
Yeah, there's no data for those groups.
So personalized medicine, it's like it can't work if your genes haven't even been studied.
It just can't.
Right. Okay. So let's dig into a specific gene. The article talks about this CYP2D6 gene.
Oh yeah, CYP2D6. Big one.
Yeah, huge.
What's so important about it?
Well, this gene, it impacts how our body metabolizes, like a quarter, 25%, a full 25% of all pharmaceuticals on the market.
Whoa, 25%. So like it's a big player.
It's a big one, yeah. And there's over 100 known variants of this gene.
Wait, what? Over 100?
Over 100. And each one, potentially impacting how people react to medication. Oh, wow, that's a lot of variation.
It is.
So like, especially in, the populations that aren't studied as much, there could be like tons of variations we don't even know about yet.
Exactly. We just don't have the data.
That's kind of scary.
It is a little unsettling, yeah. And it emphasizes the potential risks, really. Think about the codeine ban.
Oh yeah, I remember hearing about
2015 in Ethiopia. The government had to ban codeine.
Wow.
Because a huge portion of the population, they have this specific variant, the CYP2D6 variant, and it makes them convert codeine into morphine, but like super, super rapidly.
So like a normal dose for one person
could be dangerous.
Could be like really dangerous.
Yeah. For someone else?
Just depending on their genes.
Just depending on their genes, yeah.
Okay. I'm starting to see how crucial this whole diversity thing. But how bad is the problem, really? Like how underrepresented are we talking?
Well, there was this study, 2016. It looked at over 2,500 what they call genome-wide association studies. It's basically where they analyze, the genomes of huge groups of people to try and find, variants that are linked to diseases. But a staggering 81% of the samples, almost 35 million, were from people of European descent.
81%.
Yeah.
So back then, it was already like a known issue.
It was.
But you'd think it'd be, better by now.
You'd hope so.
Like that was years ago.
Unfortunately, a 2021 study, it actually found that this bias had gotten worse. European representation went up to 86%.
It got worse.
Yeah.
Oh, wow. So it's not just these genome studies then?
No, it's everywhere. You see it in services like 23andMe and databases like PharmGKB, which tracks, drug-gene interactions. Mm-hmm. So it's a systemic problem.
Yeah, it's like it's affecting how personalized medicine is even developed.
Exactly, potentially limiting its effectiveness for, huge populations.
Right.
And here's where it gets even kind of more paradoxical.
Okay.
The group with the greatest genetic diversity, the group that arguably deserves the most study, people of African descent, are significantly underrepresented.
It's like we're missing this huge piece of the puzzle.
Yeah, we are.
The article mentioned that PharmGKB, they only have like 4% of their data from this group.
4%.
Even though they have the most potential to like contribute to our understanding of personalized medicine.
Right. It's a gap that needs urgent attention if we want personalized medicine to actually work for everyone.
I mean, it doesn't make sense.
It really doesn't.
Yeah.
And it's not just about ancestry.
Right.
Gender bias also plays a role too.
Right. Women are often underrepresented in these studies too. Yeah.
Yeah, and because of that, women experience like almost twice as many adverse drug reactions as men do.
Research it often doesn't account for the differences in how their bodies process medication.
And just to add another layer to this, the article mentions people with genetic conditions, like my son, actually,
right.
or other disabilities. They're even more underrepresented.
Significantly so.
Yeah, it's like we need a more inclusive approach across the whole board here.
Yeah, absolutely. It's about, ensuring that everyone benefits, regardless of background, regardless of genetics.
Right. Everyone should benefit from scientific progress.
Exactly.
Okay, but let's not get to doom and gloom here. Mm-hmm. The article does highlight some positive stuff too. Like there's this new initiative, right, to create this massive database of African genomes.
So yes, it's very exciting.
With 500,000 volunteers.
500,000. It's a huge step in the right direction. We need more efforts like this, to bridge this research gap. Make sure, that the diverse populations are part of how we understand human genetics.
Okay, so that's really good news.
It is.
Okay, so we've like established that diversity in research. It's super important, but I think I'm still a little fuzzy on like why it's so important. Like, what are the implications of relying on this data that's so skewed towards one particular group?
That's a great question, and it leads us to some pretty fascinating points about how genetic research is actually done.
Oh, okay.
So let's explore that next. So right now, the way we do research, it kind of works on this assumption, right, that if a genetic mutation is rare, it's more likely to be harmful.
Okay.
But that assumption, it might not actually be true, especially with all this lack of diversity that we've been talking about.
So what you're saying is like what we think is harmful, like based on limited data, might not actually be harmful.
Yeah, exactly.
Okay, give me an example. Like how would this play out in real life?
Okay, well, there was this the study in March just came out, 2023, and it looked at African populations, right? And they found 44 mutations that had been labeled as, pathogenic, meaning disease-causing, but they were actually really common in these groups.
Wow. So those 44 mutations, they might be totally fine.
They might be completely benign. Yeah.
That's crazy. Like our lack of diversity, it could be like leading us down the wrong path.
It could be.
Like we could be misinterpreting, genetic info, maybe misdiagnosing people.
Yeah, potentially even, giving the wrong treatments.
Wow. Okay, I'm convinced we need more diversity.
Yeah, we do.
But what can we do about it? Like how do we make personalized medicine like truly personalized?
Well, it starts with prioritizing diversity in the research itself. Actively recruiting participants from groups that are underrepresented.
Okay, so it's not just about getting like more people involved.
Right.
It's about making sure that those people they actually represent a wide range of backgrounds.
Exactly. And it's not just about, quantity either. It's about quality too.
Okay.
Like these studies need to be, well designed, they need to be culturally sensitive, taking into account the unique needs and perspectives of different populations.
Yeah. Now that makes sense. Like we can't just, use the same old methods and expect different results.
Yeah, right.
I imagine like involving researchers from these communities would be important too.
Absolutely. It's essential, to have diverse voices actually shaping the future of research from the ground up. We need to move beyond, just like token representation.
Right.
And make sure that researchers from these communities are involved in every step. And of course, all of this requires funding.
Right.
We need more investment in research that prioritizes diversity and supports researchers from underrepresented groups.
So it's not just like the right thing to do, ethically. It's actually the smart thing to do scientifically.
Exactly.
It's about like unlocking the full potential of what we can learn,
Yeah, unlocking the full potential of scientific discovery.
Yeah, and making sure everyone benefits. But what about people who might be like hesitant to participate, like especially given the history of exploitation in medical research?
Yeah, that's a really critical point. Building trust is crucial. We need to engage with communities. Address their concerns, be really transparent about how genetic data is going to be used.
Yeah, especially with marginalized communities who might have a reason to be wary.
Absolutely.
Like transparency and respect are key.
Yeah. We need to acknowledge that history and work to build bridges, bridges of understanding and collaboration.
Right.
Shifting that power dynamic.
Yeah.
Making sure that communities they actually feel ownership over their data,
right.
And that they're active participants in the research process.
Yeah, it feels like education plays a big role here too.
It's a huge role.
Like we need to make sure that people that they understand.
Yeah.
The potential benefits of genetic research and feel empowered to participate.
Absolutely. We need to demystify the science, make it accessible to everyone.
Right.
Foster a culture of scientific literacy where people feel comfortable, asking questions, seeking information.
So instead of feeling like intimidated by the science, they could feel like empowered to use it.
Exactly.
To make decisions about their own health.
Yeah. It's about creating a world where everyone has the tools and the knowledge, to navigate personalized medicine and advocate for their own health.
It sounds like achieving equity in personalized medicine. It's like a journey.
It is a journey.
It's not a destination.
You're absolutely right. We're not going to get there, overnight.
Right.
But by taking these steps, we can definitely move closer to a future where everyone has access, to the best possible healthcare.
And what about us? Like what can we do as individuals to be a part of this change?
Well, there are a few things. We can educate ourselves about the issue, support organizations that are promoting diversity in research, encourage our friends and family, to participate in studies.
About being like informed, right? Informed advocates for our own health.
Exactly.
And pushing for equitable care.
Yeah. And don't underestimate the power of your voice.
Yeah.
Challenge the status quo. Ask your doctor about the research. Ask them if your genetic makeup might, influence how you respond to a treatment.
Those are all like great practical steps. Mm-hmm. So as we kind of wrap up this deep dive into this complex issue, I'm curious, like what are your final thoughts? Like what is the future of personalized medicine look like to you? What would it mean for us to actually achieve this vision, this vision of truly personalized, equitable healthcare? It feels like we've like just scratched the surface here, but even in this short time, it's become so clear how important this is. this whole issue.
It really is. It's a multifaceted conversation.
Yeah.
But it's kind of inspiring to imagine what we could actually achieve
Right.
if personalized medicine really, lived up to its name and truly benefited everyone.
Imagine a world where everyone, no matter their ancestry, their genes, everyone had access to treatments that were actually tailored to them.
It's a powerful vision.
Yeah, it is. It's a powerful vision.
It's a future worth striving for, I think.
Yeah.
A future where healthcare is more effective, it's safer, and it's truly equitable.
So what would it take to get there? Like what needs to happen for this vision to become a reality?
Well, we need a real fundamental shift, I think, in how we approach research.
Okay.
We need to move beyond this idea that one size fits all,
Right.
and recognize that our genetic makeup it plays such a crucial role in how we respond to treatment.
And that means going beyond just, including more diverse participants.
Yeah.
It's about making sure those studies are designed to actually capture like the full complexity of human genetic variation.
Exactly. And it's about empowering individuals to really understand their own genetic information,
Right.
and use it to advocate for their health.
Imagine being able to go to your doctor and say, like, hey, based on my genes, this treatment, it might not be the best fit for me. Like that's a whole new level of personalized care.
It is. It's a level of care that everyone deserves.
Well, I don't know about you, but I'm feeling a lot more informed.
Good.
And maybe even a little bit hopeful after this deep dive. It's easy to feel kind of overwhelmed by these big problems, these big systemic problems. But what I'm taking away from this conversation is that we can all play a role. We can all do something.
Yeah, I agree. Even small actions, they can make a difference.
So for our listeners out there, like what's one thing you would recommend they do to get involved?
Talk to your doctor. Talk to your doctor about personalized medicine. Ask them about the research behind their recommendations. Whether your genetic makeup might influence how you respond to a certain treatment.
Okay, that's a great starting point.
Mm-hmm.
And what about those who want to go a step further?
Consider participating in research studies.
Oh, okay.
There are so many studies out there that are looking for volunteers from diverse backgrounds.
Mm-hmm.
Your participation can really help, help researchers develop better treatments for everyone.
And if you can't participate in a study, you can always support organizations that are doing this work, right?
Yeah, absolutely. There are so many organizations out there that are doing incredible work, in this area.
And of course, spread the word. Talk to your friends and family about this, about the importance of diversity in personalized medicine.
Exactly. The more people who are aware of this issue, the more likely we are to see real change.
Well said. Well said. And that brings us to the end of our deep dive. I hope this conversation has given you a new perspective on the potential and the challenges of personalized medicine. And I hope you've come away feeling empowered to make a difference.
It's been a pleasure diving deep with you.
Likewise.
Mm-hmm.
And to all our listeners out there, thanks for joining us on this journey. Until next time, keep learning, keep questioning, and keep exploring this fascinating world around us.